Good day, students. Welcome to mathpreserve.com. In this clip, we're going to be going over the fundamentals of calculus part 1, namely differentiation using the power rule. If you like to ask any questions about what this presentation contains or any calculus question in general, just place your questions in the comment section below, and you can access our practice test via this link on the right. All right, so the instructions are to find the derivative of each given function with respect to x. Before we do that, we're going to go over our formulas real quick just to refresh our memories on how to differentiate using the power rule. Okay, so let's say we have some real number. For some real represented by a, we have the following derivatives. So the derivative of a prime, is 0. The derivative of ax prime is simply a. And then the derivative of x to the n, this is the power rule right here, is n x to the n minus 1. Power down, mark down, okay? If I apply this rule prime to these two, you get 0 and a. Okay, these are just shortcuts. Now, how about ax to the n? What is the derivative of that? Just simply multiply the derivative you have here with a. So you have a and x to the n minus 1. All right. Okay, so let's go ahead and get started. Question 1, we have y equals x to the third plus 4x squared minus 4. Okay, so before you apply the power rule, you have to ensure that each term of your function, in this case, you have a polynomial function with 3 terms. You want to ensure that they're all powers, and that is the case here. So now we're going to apply the sum and difference rule for derivatives. Basically, if your function is a sum or difference of terms, the derivative is basically the derivative of the individual terms. So y prime, or dy dx, is equal to x to the third prime plus 4x squared prime minus 4 prime. Okay, so we're going to go ahead and differentiate each term. So y prime is going to be, if you differentiate x to the third, you have 3, power down to 3, x to the, mark down the 3 by 1, 3 minus 1. Let's move on to the next term. You have a 4, bring down the 2, x to the, mark down the 2 by 1, minus the derivative of a constant. If you look at this shortcut here, is 0. All right, so let's simplify this, make it look pretty. We're going to have y prime equals 3x squared plus 8x. And then the 0, you can just drop that off. And this is the derivative of our function with respect to x. All right, let's take a look at question number 2. So what if we have y equals 1 over x to the third plus 4 over x to the fourth minus 2 over x to the fifth. In this case, each term is expressed in rational form. We have our variable in the denominator. So what that means is that we cannot apply the power rule directly in this case. We have to rewrite, okay? What do I mean by rewrite? We have to rewrite each term as a power. So we're going to be employing the reciprocal property of exponents to assist us in this area. So 1 over x to the third can be written as x to the negative 3. You negate the power of the term you're reciprocating, plus 4, x to the what? Negative 4, minus 2x to the negative 5. So what did we just do? We just rewrote this polynomial. Instead of having it in rational form, we expressed it as a power, okay, as a sum of powers. So this will enable us to apply the power rule in carrying out the term-by-term differentiation of this linear combination of terms. So let's go ahead and find the derivative. Y prime is going to be, of course, x to the negative 3 prime plus 4x to the negative 4 prime minus 2x to the negative 5 prime. Okay, so let's go ahead and differentiate it, applying the power rule. This becomes negative 3. Notice you take the sign of the number that you're powering down, okay? X to the negative 3 minus 1, mark it down, plus 4, power down the negative 4, x to the negative 4, mark it down by 1, power down, mark down, minus 2, negative 5, power down the power, x to the, and mark 5 down by 1. Okay, let's go ahead and simplify this. Y prime is going to be negative 3, x to the negative 4. You're adding because the signs are the same. And then here we're multiplying a positive and a negative number that yields negative minus 16. X to the minus 4 is minus 5. And then minus 2 times negative 5 is plus 10. Plus 10x to the minus 5 minus 1, negative 6. Okay, we can write the answer like this, or we can apply the reciprocal property of exponents again and express the final result, y prime, as negative 3. It's only the variable that has a negative exponent, so that's the only term, a component that gets reciprocated, okay? Minus 16 over x to the 5th plus 10 over x to the 6th. Now that is the first derivative of the original function that we have right here for number 2. All right, let's take a look at problem number 3. Now what if we have y equals 1/3 x squared plus 3 over 5 x to the 4/5 plus 1/3 x to the 1/4. Okay, in this case you have rational coefficients and also the powers are rational. Even though this problem looks hideous, it's already expressed as polynomials. Okay, each term is a polynomial term, so we can apply the power rule directly on each term. We don't have to carry out any rewriting process. Okay, so let's go ahead and differentiate each term by term. So using the sum and difference property, a rule of differentiation, we have y prime is equal to 1/3 x squared prime plus 3/5 x to the 4/5 prime plus 1/3 x to the 1/4 prime. Okay, the only complexity here is that we have to deal with multiplying fractions and also subtracting and adding fractions. Okay, otherwise it's the same as the other problems. Okay, so let's do it. Y prime is, if you differentiate here, we have 1/3. You multiply by, you power down the 2, x to the, and mark down the 2 by 1. Okay, and then let's move on to the next term. You have 3 over 5 times, you power down 4/5, and then you mark it down by 1x to the 4/5 minus 1. Okay, plus 1/3 times 1/4, you power down the 1/4, x to the 1/4 minus 1. Okay, all right, let's go ahead and simplify this. Y prime, if you multiply this across, you have 2/3 x plus, now this you can reduce, so we just multiply across. We're left with 12 over 25. X to the 4/5 minus 1 is 4/5 minus 5 over 5, which is negative 1/5. Plus, here multiply across 1 over 12. X to the 1/4 minus 1 is negative 3/4. Okay, so let's rewrite this. Applying the reciprocal property of exponents. And then we have y prime equals 2 over 3x. You can write this as 2x over 3. It's the same thing. Plus, we have 12. in the numerator over 25. Now using the nth root property, well, let's do this first. Let's write it as x to the 1/5. And then we'll use the nth root property in a second, okay? Plus 1 over 12x to the 3/4. Okay? Now this is the format if you're expressing the powers as rationals, okay? But if you want to express them as radicals, remember fractional exponents can be expressed as radicals. You can write this as y prime is 2 over 3x plus 12 over 25. Now using the nth root property, this would be the 5th root of x to the first power. So it's just simply the 5th root of x. Okay? Plus 1 over 12, and using the nth root property, the denominator of your fractional exponent is the fourth root of x to the third power. Okay, so there goes your final answer in radical form. So any of these formats are correct. You can have it like this or like this. They basically are exactly the same thing. Okay, so that's how you find the derivative. All right, let's take a look at the last problem in this series, number 4. Now, what if we have y equals 5 times the third root of x squared plus 2 fifth root of x squared minus 4 times the fourth root of x. Okay, so the question now is, can we apply the power rule directly here? And the answer is no. Well, why not? Well, the variable terms are expressed in radical form, so we have to use the nth root property of radicals to basically rewrite these terms as powers. Okay, so what we're going to do here, we are going to rewrite. Okay, so let's go ahead and do that. We're going to have y equals 5 times x to the 2/3 plus 2x to the 2/5 minus 4x to the 1/4. Okay, so let's just go over the property here, nth root property, so that you can see exactly what's going on. We use the same principle for the previous problem in rewriting our answers. So if you have, let's say, x to the n over m, this can be written as the mth root of x to the n, or you can also write it as the mth root of x, the entire thing raised to the nth power. Okay, but we're using this representation right here. So you can go both directions, either from left to right or from right to left, still exactly the same thing. Okay, so now that we have every term written as a power, we can now find the derivative. Okay, so y prime, using sum of difference property of derivatives, we have 5x to the 2/3 prime plus 2x to the 2/5 prime minus 4x to the 1/4 prime. Okay, so we can just factor out this constant and then multiply it by the power rule being applied to x to the 2/3. So you power down 2/3 times x to the, and then you mark down the power by 1 minus 1 plus 2 times power down the power 2/5 times x to the 2/5, the power minus 1, and then minus 4 power down 1/4 x to the 1/4 minus 1. Okay, so that's how you apply the power rule to each term. Now let's go ahead and simplify it and apply the nth root property to express rational exponents as radicals. Okay, so simplify first. Y prime is equal to 10 over 3 x to the 2/3 minus 1 is 2/3 minus 3 over 3, which is negative 1/3, plus 4 over 5, just multiply across. X to the 2/5 minus 1 is negative 3 over 5. And then these 4's divide out. And you're left with minus x raised to the 1/4 minus 1, which is negative 3 over 4. Now we're going to apply the reciprocal property of exponents in rewriting these negative exponents as positive exponents. So y prime is going to be 10 over 3x to the positive 1/3. When you reciprocate, you invert the sign, okay? Plus 4 divided by 5x to the 3/5 minus 1, that's the coefficient of x right here, over x to the 3/4. Now you can write it like this if your answer is going to be expressed as rational exponents, or you can write it as radical exponents, expressed as radicals by applying the nth root property of exponents. In that case, we're going to have y prime equals 10 over 3 times the cube root of x plus 4 over 5 times the 5th root of x to the 4th power minus 1 over the 4th root of x raised to the 3rd power. Okay, so there goes the derivative of the original function in whichever format that you like. Thanks so much for taking the time to watch this presentation. Do give us a thumbs up if you find the contents of this tutorial beneficial to you. Your positive feedback is valuable to us. Don't forget to subscribe for updates to the remainder of this preparation series for calculus. Any questions as indicated earlier, just place your questions in the comment section below. And don't forget to take our practice test. Thanks again for watching and have a wonderful